Head of Mechanical Engineering Department at Vigyan Institute of Technology and Science. I welcome all the participants and resource persons to this 1 week FDP on potential research areas in mechanical engineering. Till yesterday, we have got around 1,000 registrations and the response is excellent. And I thank all the participants for showing faith in us and registering for this particular FDP program. Thanks to all our faculty, we were able to rope in reputed researchers from all over the world. And next 6 days, they will be discussing and they will be projecting some of the areas in mechanical engineering as potential research areas. Young faculty with MTech degree in mechanical engineering, for them these sessions are very useful and they will get some direction to pursue their PhD and to publish some quality papers. Without going much into the formalities, I want to introduce the first resource person, Dr. K. Venkat Rao. He is our own faculty. At present, he is working in Vigyan Institute of Vigyan University, Guntur as professor. He has around 40 publications and 19 of them are in SCI indexed journals and 5 of them in ESCI indexed journals and 16 of them in Scopus indexed journals. And he has 5 more publications in international conferences and he is reviewer for 10 SCI journals. Under his guidance, 2 research scholars completed their PhD and 5 more are pursuing their PhD under his guideship. He has 1.5 crore worth project grants under his belt. He has delivered guest lectures in reputed institutions like NIT Warangal. With rich research pedigree, we are fortunate to have him as resource person for today's FDP session. And he is role model for all the faculty in Vigyan group of institutions. Thank you so much, sir, for accepting our invitation to be resource person for this particular FDP. And now I welcome him to take over the session and deliver his presentation. Thank you, Dr. K. Venkat Rao, sir, and thank you all the participants. 1 minute. Video. Okay. Sir, before starting SAR's presentation, we want to play a small video about our department and about our institute. Sir, are you able to? One minute. Video clip is. Sir. Okay, thank you. Video is there.
Okay, you have not downloaded, sir.
Six.
No, that's it. This one, na? You have to go to YouTube and that you have to share. Computer audio with. How did you get computer audio? Computer audio. How do you go? Record on this computer audio. Share computer sound, huh? This one.
Sir, Dr. Venkatrao, sir. Sir, please take over the session.
Okay, thank you. Thank you. Please guide me for 1 minute
Okay, sir.
until I share the PPT.
No problem, sir.
Okay. Okay. Okay, sir.
Yes, sir. Yes, sir.
Thank you, sir. Thank you.
Right,
I
sir.
will start, sir. Okay. Good morning to the all participants. Before starting the session, let me convey my gratitude to the management of Vignan institutions and principal of Hyderabad Vignan College and HOD of Professor from Vignan Foundation for Science and Technology discuss the university modeling of computer interface of conditioning by vibration.
మ్యూట్లో ఏమైనా పెట్టుకున్నారు సార్ ఆయన చెక్ చేయండి సార్ సార్ ఆయన చెక్ చేయండి మ్యూట్లో పెట్టుకున్నాను
Sir, Venkatrao sir, sorry for the technical problems at the beginning of the session. Please go ahead with your presentation, sir. Sir, still we are not able to hear your voice, sir. Sir, please unmute. Please unmute.
Okay, now?
It's fine. It's fine, sir. Fine, sir.
Are you hearing me well?
Yes, sir. Yes, sir.
Okay, 1 minute.
Please go ahead with your presentations.
Okay. Thank you, sir. Now it's fine.
Yes, sir.
Thank you. Okay, I'm starting from the beginning, that slide 1. Okay, during the Second World War, there was a lot of demand to meet the demand that equipment which are used during the war. At that time, they used super alloys which are having low machinability, means they are very hard to machine. That's why that super alloys are called as difficult to cut metals. So nowadays we are using the Inconel, titanium alloys. These alloys are also very hard and having the low machinability and difficult to machine. So in conventional machining process, all the complex shapes cannot be made. Sometimes in machining of complex components, we need some machining process like unconventional machining process, which we are seeing that wire electric discharge machining process. It is one of the unconventional machining process are used to machine hard metals. So here hardness of the workpiece is not matters to the unconventional machining process. That wire EDM, irrespective of the hardness of the workpiece, it is able to machine any kind of metal which are having low machinability. Not only the machining ability of machining the hard metals, so it is also able to fabricate the components with the required surface quality and dimensional accuracy also. Dimensional accuracy plays an important role, which is to be achieved during the machining process. If the dimensional accuracy is less, the component may be rejected. That is the problem. That's why this iridium is able to produce high precision in dimensional accuracy, as well as the good surface quality of components can be produced. So most of you know about the electric discharge machining process that we are seeing in the BTech also, and this I'm showing the okay. So this the figure shows the wire electric discharge machining process. So here if you see where we have workpiece is held on CNC table. Generally, iridium is performed on CNC machines, where the workpiece, that is the work plate, is moved in X and Y direction as per requirements by the CNC machine. So the workpiece is held on the CNC machine table. Then the table can be moved in X and Y direction as per the profile of cut you want to made. So during the machining process, as per the profile which you want to cut, according to the specifications, dimensions of the profile, CNC program will be written. As per the CNC program, that table is moved with respect to the wire. If you see this one, we have uh, two wire reels. One is supply reel and another one is take up roller. So where the wire is moving through the guide rollers, and used wire is taken by the take up roller. Bottom is called as take up roller. Sir, please, that host, I request you to unmute all the participants. Continuously, I'm hearing some sounds that some participants, while they are typing, that message sound is also coming. Please mute all everything except my voice. Okay, thank you. See here, if you see, uh, say the wire is supplied from this top roller, supply roller, and it is moving in this towards downwards, and at bottom we have take up roller that is taking. So between the wire and workpiece, series of sparks are generated. How the sparks are generated? That wire is acting as electrode which is connected to negative terminal, workpiece is connected to the positive terminal. When the current is passed across the electrode, the wire is connected to negative terminal, it releases electrons. That electrons come called as primary electrons. They come from the electrode and passing through the dielectric fluid to the workpiece. When the dielectric fluid is supplied, molecules in the dielectric fluid are struck by the electrons. So where the bombardment of molecules will takes by the electrons which are released by the electrode. Then, during the bombardment, the molecules are divided into positive ions and electrons. So, these released electrons are calling as secondary electrons. Finally, number of electrons will be increased. That is, primary electrons which are released from the wire. After bombardment, also some electrons are released. So finally, amount of electrons are more which move toward the workpiece as the workpiece is connected to the positive terminal. At the same time, positive ions are moving towards the wire. These positive ions also striking with the wire. Continuously sounds are coming. I am requesting the host, please mute everybody. That messages, all the things disturbing. Okay, please. And so here what is happening? Here during the process what is happening, positive ions striking the electrode. Okay, however electrons striking the workpiece which causes in the form of the workpiece and remove the workpiece material. So in this way, uh, thank you. In this way, the workpiece material will be melted and evaporated. That removed material is taken away by the dielectric fluid which is used. Here you have to see one thing. Once the wire is used, once the sparks are generated between the wire and the workpiece, we are calling that one as used wire. That used wire will be supplied bottom and it is taken by the take-up roller at bottom. This is the process. If you see at right side, you have the profile which is cut during the wire EDM. So here wire is stationary, that is held vertically against the wire, the workpiece is moved. So here if you see in the right side where the profile of cut made by the wire EDM, see this one, the slot is called as kerf or kerf width. The kerf width is, it can be can be measured under the machine vision system or other measuring device we have. Using that optical measurement system, the kerf width can be measured. So the kerf width can be estimated as wire diameter plus 2 into spark gap. Yeah, if you see in this direction, we have both the sides, you have the spark gap. So the spark 2 into spark gap plus wire diameter is equal to kerf width or the size of the slot. See bottom of this figure, that the complex shapes which can be made by the wire EDM are shown. So aim of the So aim of this presentation is we want to study the effect of wire vibration on the kerf width, that is size of the kerf width as well as the surface roughness. That is our title also, modeling and optimization of wire vibration in wire EDM of hard metals. So here if you see, thing is that in the previous slide, once again I am going to the previous slide. This is the component at right side. You can see that if you keep this one under the micro, that is machine vision system, you can measure the kerf width as well as the surface roughness can also be measured. But thing is that in the second slide you can see at the bottom figure number 2 here, if you see, you can observe at top width of the kerf is more at bottom when compared with top and bottom surfaces. At bottom you will get the less size. Less size means not in mm, in microns you will see the less size. So a top side, it appears like just like a cone shape, that cutting if you observe taper shape. So that is why you cannot justify the measurement of surface roughness under the machine vision system or microscope, whatever the optical measuring system you used. You cannot justify. So sometimes if you cut the workpiece from one end to another end, then easily you can measure the vibration, that surface roughness using we have different measuring device, telesurf and profilographs, like that. We have different measuring equipment. Using those things we can measure that one. So here, if the cut is made up to some length, not other end of the plate, so it is difficult to measure the surface roughness. Such cases, what we are doing, so we are taking the wire vibration, that is amplitude, displacement of wire in x direction and y direction, and frequency. Considering those things, the kerf width and surface roughness can be modeled. That we want to see in this presentation. See here, okay, already we know that kerf width and surface roughness are affected by the wire vibration. Before seeing that one, see this in the first slide. So where we have this one is wire. Again, that is wire. This is stationary. It will not be moved. The workpiece is moved in the x direction from left side to right side. When the sparks are generated between the wire and the workpiece, the work will be the wire will be vibrated in x direction and y direction. This is the displacement of wire in x direction, displacement of wire in y direction. If the displacement of wire vibration in x direction is more, which is acceptable because it improves the cutting rate as well as the metal removal rate, there is no problem of this one during the machining process. When the wire is vibrating in the y direction, that will be the problem, which greatly affects the kerf width as well as the surface roughness. If you are able to control the wire vibration in x, no problem. In y direction, where you can get the required width of kerf and the surface roughness also. Here is problem is that we cannot control. Here we have many problems. So once again, we go to the first slide. So here, if we say wire tension is one of the important parameters here we have to consider. So generally we have the input parameters like current, voltage. Most of the cases voltage we are taking as fixed value. Current is one important parameter. Wire tension, T on, T off. That is pulse on time, pulse off time. In microseconds we are taking. Pulse on time, which represents the duration through which the current is passed across the wire and workpiece. That is pulse on time, and pulse off time. That is duration. During the duration, we don't supply the current. So we are supplying the current across the electrode in the form of pulses. So for that one, we have different power supplies also that we are using in that arc welding, that is MIG welding. In MIG welding also you see different types of modes of metal transfer. Pulsed mode of metal transfer, that fourth one we have, fourth mode of metal transfer, where we are using this kind of power supply. Okay, we have that power supply. Just like pulses, it supplies the current across the wire and workpiece. So there is no problem of getting the T on, T off time. So the duration can be increased, the duration can be reduced. As per our requirement, we can set this. So, however, all the CNC that wire EDM machines are available in the with CNC control system. So we can control the T on, T off times. Even current also can be increased or decreased. All the things are available with the machines which are available now. Okay, thing is that here wire tension is a very important thing. So if the wire tension is I told you in this slide, I told you vibration of wire in x direction promotes the metal removal rate. Vibration in y direction changes the kerf width, affect the kerf width and surface roughness. Okay, to reduce the wire vibration in the y direction, if you increase the wire tension, see this one, if you increase the wire tension, that vibration amplitude, displacement of wire can be controlled in x and y direction also. But thing is that in iridium, diameter of wire is around, that is less than 0.5 mm. Sometimes we use, in the present study, we used diameter around 0.3 mm diameter. So that is almost 300 microns. Even you cannot see that wire during the event. Physically, we cannot see that wire. That is the diameter of the wire we are using. If the wire tension, we can kept up to 18 newtons. If you give maximum wire tension, when the positive ion strikes that spark strike the electrode, then what happens? That the break of wire will take place. When the wire is when the wire is cut, the total machining is to be stopped, and again wire is to be cut and set to the take up roller. Those are the problems in that one. That's why you have to reduce the wire tension. If you reduce the wire tension to avoid the cutting of wire due to sparks, then what happens? There is tendency of wire displacement. That is the problem. So that is why we model the wire vibration to reduce its effect on the kerf width and the surface roughness. So now see this one. To study the effect of wire vibration in x and y direction, first of all, we have to measure the displacement. Here, I request all the participants, please listen carefully from now onwards. So here it is required to study the effect of wire vibration on the kerf width and surface roughness. We have to measure the wire displacement in x and y direction. So in 2016, Habib Samesh and Akira, so the reference was also mentioned in the slide. This paper was published in Journal of Material Processing Technology in 2016. They made an attempt to measure the displacement of wire along with the frequency in x and y direction. So where they used a digital high-speed video camera, that model was also given, Kian's VW6000. So they used this camera to measure the vibration of wire in x and y direction. So capability of this wire, it is able to generally a camera which we are using that captures the 23 to 26 frames per second. But this video camera is able to capture the frames, that is 8,000 to 23,000 frames per second. That camera is able to capture the wire. Cost of this one around 18 to 22 lakhs, that this camera. So here you see what they did. They measured the vibration in x direction and y direction using this camera. To measure the displacement of wire in x direction, they kept the camera in y direction. To measure the vibration of displacement of wire in y direction, they kept the camera in x direction to measure that one. Okay. So simultaneously, the camera is not able to measure the wire vibration, that is displacement of or amplitude of wire vibration in x as well as y direction. Simultaneously, it is not able to measure. So it is possible. First, they measure the displacement of wire in x direction. After that one, they measure the displacement of wire in y direction. So both the things cannot be synchronized. So time factor is important. At a particular time, what is the amplitude frequency of wire in x direction, y direction? So that synchronizing the both the values is difficult with this video camera. What these two others did, that Samesh and Akira, they measured the vibration of displacement of wire in x and y direction using that camera, and maximum values were taken for their analysis. That one also is not giving the required analysis, and that is, we cannot justify using those measurements of wires is in X and Y direction, not simultaneously, separately. So here thing is that the wire vibration is to be measured in X and Y direction simultaneously. Then only it is possible to say at this particular time period. That is important here. At that particular time period, what is the amplitude of wire in X direction, Y direction? That is the problem with limitation with this high-speed video camera in capture of the in measurement of the wire vibration in X and Y direction. So here, before seeing these slides, with that one, let us see the effect of wire tension. So in the schematic diagram A, if you keep the wire tension, less wire tension, see this one, displacement of wire is more. At center you see where the displacement of wire in X as well as Y direction, displacement of wire is more. So when you keep the less wire tension. So if you keep the more wire tension, see this one, amplitude of wire displacement is less, and you can see the two number of nodes here. If you are able to place the workpiece at this node, this effect of wire vibration on the curve width and surface roughness can be minimized. Even if you keep at center also, it doesn't matter when compared with figure A. At figure B, anywhere you place the workpiece, effect of vibration on the curve width and surface roughness is found to be less. Thing is that in the B, you got less wire displacement due to wire tension, more wire tension. There is difficulty with this more wire tension. What is the difficulty? If you say there is a chance of break of the wire when the high sparks are generated. For suppose if you want to increase the T on time, or if you want to increase the current, then what happens? The wire will become unstable and break. So total machining will be done again. So now what happens at figure A, if you see, if you reduce the wire tension, okay, that loose wire you will see. And one more thing is that when the spark, see, we are using the ductile material here. Wire is ductile material. Due to sparks, the wire is deformed. So here wire is deformed, then it increases the wire displacement. That is, length of wire will be increased. It's enough increase not required in the MMs, even in the microns. If the it affects the that is the thing you will see here. So here we have to use the we have to maintain the optimum wire tension. You have to maintain the optimum wire tension. Okay. Before seeing modeling, just I will show one. See this one. This is the experimental setup which prepared by us, myself, my scholar, and another my colleague. We developed this. See that problem with Akira and the other person, where we have seen it is not possible to measure the wire vibration in X and Y direction simultaneously. That is the problem we found there with that work. So in this work which we prepared, see, we have taken an accelerometer which is arranged to the wire guide at top guide roller. At the bottom, the accelerometer is adjusted to touch with the wire. So during the machining process, the wire vibration can be measured by the accelerometer simultaneously in X and Y direction. Then we can study the effect of wire vibration on the curve width and surface roughness. That is what we did with myself and one of colleagues and one of my scholars. We developed this experimental setup, and the wire vibration we measured in X and Y direction using the accelerometer simultaneously. With respect to time, we get the synchronized results of the wire vibration in X and Y direction. Now it is possible to use this data to analyze the effect of kerf width, effect of the wire vibration and kerf width on the surface roughness. Before using that vibration data, let us see the modeling of the kerf width and the surface roughness. See here, kerf width and surface roughness are two important machining characteristics affected by the vibration of wire, and vibration of wire is mainly influenced by the wire tension and current. It is not said by me. It is said by the previous researchers what they found in their study. And one more thing, the Samesh and Akira, they reported that the wire is assumed to be vibrated elliptically during the machining process. We know the elliptical path, not in circular path. In elliptical path, the wire is vibrated. That one also I will show in the next slide how it is vibrating in the elliptical path. But the displacement of wire in X and Y direction has significant effect on, as already I told you. And just before also I told you displacement is nothing but amplitude of wire vibration. In X direction promotes the more that metal remove rate, but its effect on kerf geometry and surface roughness is less. But the wire displacement in Y direction has significant effect on the kerf width and the surface roughness. Okay, now you see how the wire is vibrating. See this one. This is elliptical path. In this elliptical path, the wire is assumed to be vibrated. So it is vibrating in this direction. That is why the profile also, see this one, irregular profile we are seeing. Irregular means it is not so irregular. So the height of T or a theoretical roughness maybe 1 micron, 2 micron, 4 microns like that. Okay, see this one. The wire is these all the stars representing the spark gap, that is spark length. Spark gap, spark length, both are same. See this one, AX is the amplitude of wire vibration X direction, AY is the amplitude of wire in Y direction. See in the AX and AY direction, that you will see the maximum displacement of wire. In AX is the maximum displacement and AY is the maximum displacement in Y direction, and remaining all the sides, the displacement if you see less than AX and less than the AX. Now if you see where the that is we can measure the displacement of wire in X and Y direction using the accelerometer. So not only the displacement of wire wire vibration, that accelerometer also measures the frequency of wire vibration also. What is the amplitude of wire vibration? With what frequency that is vibrating in X as well as Y in both the direction. The data can be collected with the help of the accelerometer. This work we did just recently. This work was published in SCA journal, that is IMechE Party Journal of Process Mechanical Engineering. That reference was also shown at the bottom of this one. And now you see in the modeling of kerf width, see this one in before slide also. See in that path we are showing A, B, C. So the work that wire is vibrating in this direction, that moves from A to C through B. That is what we have to assume. That is in elliptical direction it is vibrating. That is why it is moving from A to C through B. In the next slide, see this one. As the wire is assumed to be vibrated elliptically during the machining process, the surface roughness kerf width are modeled using the amplitude frequency of wire vibration in X and Y direction. The work is fed against the wire electrode and the wire starts machining at point A to point C through point B. So the time thing is that at A you have the maximum height of the kerf. At C also you have the maximum height of the kerf. And we want to find out the time between T and C. If you are able to estimate the time at instant, that is times at A instant and B instant, then you can model the that is model the curve fit and surface roughness using the vibration of wire in X and Y direction. So next slide, you see this one. So here you can see, so we know the AX is the amplitude of wire vibration X direction. AY is the amplitude of wire vibration Y direction, and the position of wire with respect to, that is during the machining process, position of wire in terms of X coordinate, Y coordinate can be modeled at particular time instant. Xt is equal to X into cos omega t minus VCT. VC is cutting velocity. During the machining process, nowadays we have all the CNC machines. The CNC machine on the display, you will get the value of VC. There is no problem of the cutting velocity. In the display, you will directly, you can record the cutting velocity during the wire EDM. So now with the accelerometer, we can measure the wire vibration in X and Y direction in terms of amplitude and frequency. Using that frequency in the equation number 3, you can find out the omega using the frequency of wire vibration. Then here we can model the position of wire in X and Y direction. In the next slide, if you see velocity of wire, we should know the velocity of wire, then only it is possible to model that one. See this one, velocity of wire in X and Y direction can be obtained by differentiating the previous equation 1 and 2. Then the transient velocity in X and Y direction can also be estimated using this equation 4 and 5. Now finally, if you see the curve fit at particular time instant, at particular time period t, already we know the remaining values. Ay is the amplitude of wire vibration in Y direction. Fi is the frequency of wire in Y direction. R is the effective radius. I will tell now. Ax is the amplitude of wire vibration in X direction. Fx is the frequency of wire vibration in the X direction. So like that, all the data available with us, that is with accelerometer, we measure the amplitude and frequency of wire vibration in X and Y directions. So here, all the values we know, Ay, Fi we know. Here also Ax, Fx also are known. We don't know the Re and T. Re is the effective radius of the wire. What is this effective radius? How we mention? So already before using, when you selected the wire, we know the diameter of wire. So here we are talking about the effective radius that we see here. See that in the first figure, Re is the effective radius. See this one, effective radius is obtained by adding the spark length to the radius of wire. If you add the spark length to the radius of wire, it will be the effective radius of the wire. So how to measure the spark length? So it is not possible to measure the spark length directly. In the study, what we did on conventional EDM, for suppose we conducted in the study for 16 experiments at 16 currents and T on T off times and Y tensions. So here what we did, at different working conditions which followed in the study, at the same working conditions, EDM experiments we conducted. After conducting the EDM experiment, if you measure the diameter of hole from this one, from the diameter of hole which is made in that conventional EDM, that diameter of hole minus electrode diameter, it gives the spark length. Once you get the spark length, sir, please host, I am requesting you continuously. I am getting the disturbance, that messages, sounds are coming. Please mute everything. It is difficult to me to concentrate on the presentation. Host, I am requesting you, please mute all the voices. Continuously messages are coming, screen is getting disturbed, and I am not able to concentrate on the presentation. Please. Right. Okay. So here, The spark length on conventional EDM we can measure. That using the spark length and the wire radius, you can get the effective radius of wire. Still it is coming. Difficult to concentrate. Now, in a similar way, the surface roughness can also be modeled using the amplitude and frequency of wire vibration. See this one here, it is showing alpha is the angle of transient velocity. So here also we can estimate the theoretical height of surface roughness. If you TRA is nothing but theoretical roughness. So where AY into cos omega TA plus phi plus RE, that is effective radius 1 minus cos alpha into omega TA plus AY. AY is the amplitude of wire vibration in Y direction. So here AY is known value, omega is also known value. Previous slide we have seen pi is also known value. RE also is known value here, effective radius. We don't know the value of TA. That is that instant time at point A. What is the time period? We don't know. To estimate the time instant at TA and TC, we have two equations which are proposed by these two researchers in 1994 and 2013 also in MATLAB. In MATLAB, using these two equations, we can estimate the TA value also. So here, TA, TC are unknown values. We know the velocity of cutting, pi value is known, RE value is known, AY and AX values are known. Except TA, TC, all the values are known. Using the MATLAB software, solving the 9 and 10, we can estimate the time periods TA and TC. Using TA and TC, that theoretical roughness and theoretical, so here also T value TA, theoretical curve fit, both the things at a particular time instant you can estimate. That is called as modeling. So modeling, in the modeling we can estimate or predict the curve width and surface roughness. So like that we can estimate curve width and surface roughness using the experimental data of wire vibration, that is amplitude and frequency of wire vibration in X and Y direction. This is the experimental setup already I explained. And next one, if you see the experiments conducted at different, these are the parameter. What is the workpiece material, wire material, distance of wire guides from the plates, that is above the plate 100, below the plate 100. If the plate thickness is 5 mm, total gap is 205 between the two guides. That is total length of wire. Dielectric deionized water is used as dielectric fluid. Voltage is taken as main voltage 90 volts, gap voltage 30 volts. Wire velocity, wire diameter 0.3 mm. Here we took the wire tension 16 newtons. All these things are parameter setup. So at different working conditions, see this one, this is the experiments which we conducted. See this, these are at 4 input parameters we have taken, that is I, the current, wire tension, T on, T off, and this is the output value we can directly record from the machine using the thickness of wire and current, thickness of the plate and cutting rate. We can estimate the metal removal rate, AX, FX, AY, FY. These are measured using the accelerometer. That curve width is predicted using the equations which we developed in the study. This one is RA is also predicted using the model which we developed in the study. And experimentally, that is under machine vision system, we measured the curve width simultaneously, this roughness also. When you compare these two, almost both the things are found very close together. And so how we measure the surface roughness here, after machining, that workpiece is separated, that cut mode and we direct right. Okay. This TA value is obtained using the equations previously just before I shown. These equation 9 and 10, we can estimate the TA and TC value. Now, for this is the variation of wire measurement in X and Y direction. See this one. This is in X direction. This is the maximum amplitude, that is 24.28 micrometers with frequency of 59. So this is in X direction. Y direction, maximum amplitude you can find 18.68 micrometers with frequency of 67 Hz in Y direction. So this shows the measurement of wire vibration in X and Y direction directly. So these are the profiles in that 16 experiments, that is cap width profile and surface roughness heights are also shown in this table number 3. So these figures shows the interaction effect of the current along with wire tension T on and T off time. If we see the amplitude of wire vibration X direction, if we observe the, if we see the interaction graphs, where the in the first figure, in the 3 figures, as the current is increased, wire displacement is also found to be increased in X direction as well as the Y direction. In the figure A and D, if you observe, if you increase the wire tension, amplitude of wire vibration is getting reduced. That you can see in case in vibration in X direction, in the Y direction also. In the Y direction, clearly you can observe. If you increase the wire tension, that amplitude of wire vibration Y direction is getting reduced. That clearly you can understand. So if we see the current and the wire tension are having 74 and 23% of contribution on the displacement of wire vibration in X direction. In Y direction, if we say the current as well as wire tension both are having almost the wire tension is having more influence than the current on the wire displacement in Y direction. That's why we want to optimize the process parameters to reduce the amplitude of wire vibration in X as well as Y directions. So here now we are going for the almost we completed the modeling of that one, mathematical modeling we have seen. Now we go for the optimization. So there are different types of optimization techniques like Taguchi method, everybody knowing this one. Next one is response surface methodology, gray relation analysis, particle sum optimization, teaching learning based optimization, graph theory matrix approach, and utility concept. Now this is very important thing. All the participants are requested to listen carefully. What are the advantages and limitations? First I am talking about the limitations in all the machines and one method which we have to select as per our requirements. First let us see the Taguchi method. It is in the Taguchi method, design of experiments can be carried out, and the Taguchi method estimate the signals to noise ratio for all the output characteristics. So signal to noise ratio, signal represents the required value, noise represents the unwanted value. When the signal to noise ratio is more, unwanted value is less, then the results will be good. Thing is that, for suppose we have 3 inputs, say current, T T on T of wire tension, where we have the 4 outputs. Let us take the surface roughness, metal removal rate, kerf fit, 3 outputs. The Taguchi optimized the process parameters for maximum metal removal rate separately, minimum surface roughness separately, minimum kerf fit separately. Please listen carefully. For maximum metal removal rate, the Taguchi method optimized the process parameter, one set of process parameters. For minimum surface roughness, the same process parameters it will not give for the surface roughness. Similarly, for the kerf width also, same optimum input parameters it will not give. Okay, one example I will show you. See here, for cutting rate, see this one, where we have amplitude of wire vibration x direction, cutting rate y direction. 3 responses we have taken here. For minimum wire vibration x direction, the process parameters optimum levels is 69630. For wire vibration in y direction, 315,930, and cutting rate 6, 15, 15, 60. So for any two also, the optimum levels are not same. This is this optimization is done using the Taguchi method. So for AX we have one set. For CR we have one set of optimum inputs. For AY also we have one set of inputs. So if you use any one of these 3 conditions, remain 2 will be affected. You may not get the maximum CR. Actually, we need the maximum CR and minimum AY. So if you use these working conditions, that is for AY we got one working condition, 3 amperes of current, 15 newtons of wire tension, 9 and 30 microseconds of D and T of respectively. If you use this working condition, the above things you may not get optimum. That is the problem with the Taguchi method. And another method, if we say response surface methodology. So here you can overcome that difficulty. In the response surface methodology, for the 3 inputs where we have cutting rate is to be maximized, AX and AY, that is amplitude of wire vibration X and Y direction, can be minimized. So vibration can be minimized, and say that CR cutting rate will be maximized. For these requirements, it gives one combination. If you use that one combination, cutting rate will be maximum, AX and AY will be minimum. The problem which you are seeing in the Taguchi method can be minimized in the RSM method and in the GRA method also. First, let us see the RSM method. So in the RSM method is what happening if you see. Okay, it gives one set of input parameters as optimum working conditions with the maximum cutting rate, minimum wire vibration. Thing is that in the response surface methodology, the cutting rate, the remain 2 amplitude of x, amplitude of wire vibration x direction and y direction, the 3 are given equal weightage. 3 are given equal weightage, 0.33, 0.33, 0.33. Sum of the weight of these 3 parameters should be equal to 1. In response surface methodology, 0.33 weightage for each output characteristics, each response it will be given. So that is thing in response surface methodology. In the gray relation analysis, see, during the response surface methodology, we can select maximize CR, maximize AX, minimize AY. That can be option where we are in RSM. In GRA, it is not possible. In GRA, the 3 values are taken into one response. That is the problem with the GRA. Individually, that responses cannot be defined. That means what is its requirement, that will not be given in the GRA. That is why GRA is not so popular like RSM method. Now, teaching learning based optimization technique. Generally, teachers what they follow to improve their pass percentage in their subject. Well, generally, what the teacher will do after conducting unit test one, mid one, they will identify after mid one, they identify, that is slow learners and fast learners and slow learners. What the teacher will do, an interaction is promoted, interaction is allowed between the intelligent student and poor student. Then the teacher will pair, yeah, that is fast learner to slow learner. Then the knowledge is transferred from the fast learner to slow learner. Then the performance of slow learner is also increased, and finally class pass percentage will be increased. That is the concept of the TLBO, teaching learning based optimization. That a very good tool, we can say. The TLBO method, nowadays it is very popular. The people who publish, who write the papers using the TLBO method, their papers are getting accepted even in the most of the cases in the SCI journals. So you can try with this TLBO. And another one is graph theory and matrix approach that we are going to see in the next slides. That combination of graph theory and matrix approach along with the utility concept, along with the utility concept. So now particle SAM optimization. Okay, I have little knowledge of this one. So this particle SAM what it will do, it is this one also similar to the TLBO method. It classifies the experiments, that is students, like clever students, slow learner, medium learner, like that. It classifies this particle SAM optimization. So, in the above methods, except that TLBO method, you have another facilities also. You can use the constraints also. That other things are also there. So, except this TLBO method, the Taguchi, RSM, GRA, particle SAM optimization, where we have some limitations. That limitations can be overcome with graph theory and matrix approach. And the problem is that Taguchi method, this is single response optimization technique. RSM and GR are the multi-response optimization techniques, but they give the equal weightage to the responses. For suppose, let us see. Okay, in the next cases we see those things. Next, this one is graph theory and matrix approach. So here it estimates the weights to the output characteristics, that responses scientifically, not just like that. Okay, cutting rate, it improves the metal removal rate. We can give the 0.5 weightage to that one. Okay, next one is amplitude of wire vibration. Okay, this is affecting the surface roughness as well as kerf width. For the consumer who uses the product, he needs the dimensional accuracy in the curve width and less surface roughness. That's why the consumer will give the highest value to the amplitude of wire vibration in y direction, because it is affecting the curve width and the surface roughness. So like that, all these things will be taken into the considerations, and the weightages are estimated for the responses. In the next slides you will see. Listen, జాగ్రత్తగా వినండి. So this is utility concept. Again, this slide will come. This is graph theory and matrix approach. This was developed by the IIT Delhi. Was developed. See this one. There are 4 users: user 1, user 2, user 3, user 4. There are 4 users having 4 preferences. User 1, if you see, he gives high priority to the amplitude of wire vibration y direction, because it is affecting the kerf width and the surface roughness. He is the consumer. He gives high priority to the AY because it is affecting the surface quality. So that's why AY is given highest priority. CR and AX will be given the next priorities. User 4, if you see, user 4, he is manufacturer. He doesn't bother of the quality of kerf width and surface roughness. He wants to improve the metal removal rate. If you improve the metal removal rate, that power consumption for him will be reduced. He doesn't bother of that one. So that's why he gave highest priority to the CR, next priority AY and AX. User 2, if you say he is reasonable manufacturer, he gives priority to the metal removal rate as well as AY, as the AY is affecting the kerf width and surface roughness. Least priority is given to this one. Next one, user 3, if you see, he gives highest priority to the AY and the least priority, next level priority is given to the cutting rate as well as the AX. Like that, here the number of users can be increased. If the number of outputs are more, the number of users can also be increased. Even here you can add another 50 user also. It doesn't matter. Number of users can be anything. Based on their opinions, we have to estimate the weight to the responses AX, AY, and the CR. So how to estimate that one? First you have to construct a preference graph. If you see this matrix, don't worry about this matrix. Just you see this one. This is developed by the Manjot S. Chima. He is professor at IIT Uttarakhand. Dehradun is professor at there, and he developed this concept. That is from this graph theory to construction of this preference graphs. You see this one. See AY, CR, AX, and AY, CR, AX are taken vertically and horizontally. So you see this one in this matrix, 1 by 1 matrix here. If you see, it is 0, means there is no direct connection from AY to AY. Next, CR to AY, you have the connection arrow. That's why it is taken as 1. So from there is no direct contact from AX to AY. That's why it was taken as 0. Next one, if you see AY to CR, AY to CR, there is no connection. CR to CR, there is no connection. But AX to CR, you have connection. That's why it was taken as 1. So next one, if you see AY to AY0, AY to CR, no connection. That arrow direction you have to see. AY to AX also, you don't have the arrow. That's why you have taken 0. Similarly, here also, these remaining preference graphs are to be constructed. Once again, I am saying, so all these preferences are collected based on their requirements. That's why 0 and 1 values are assigned. 0 indicates that there is no connection. AY to AY, no. CR to that is okay. CR to AY, you have the connection arrow. That's why it was taken as 1. CR to AY, you have the connection. That's why you have taken 1. AX to AY, there is no direct contact between CR. You have between them. That's why it was taken as 0. Next one, AY to CR, no connection. CR to CR, no connection. And AX to CR, you have the connection. That's why it is taken as 1. Similarly, remain preference graphs also constructed. Here it is not required to bother. Very easy thing, this one. Next one, you see dominant matrix is to be estimated. Dominant matrix nothing but for D1, if you see preference graph 1 plus preference graph that is the preference graph square. So like that. For suppose you have the n is equal to 3, number of individuals 3. For 3, that is D1, how we are estimating PG1 plus PG1 square. That's all. PG1 plus PG1 square. Next one, D2, if you see PG2 plus PG2 square. D3, PG3 plus PG3 square. D4, PG4 plus PG4 square. So here you see for D1, PG1, this matrix, PG1 matrix plus into PG1 into PG1, that is PG1 square. So like that we are getting the dominant matrix. From the dominant matrix, relative degree of performance is to be estimated. See this one, how to estimate RDP is also equation is given. If you see this one, see this, all the rows for this one, for RDP1, I am talking about the RDP1. So here for all three rows you have to add 1 as for this one. 0 plus 1 plus 1, 2 plus 1 additionally you have to add. So 3 here we have. Similarly 0 plus 0 plus 1, 1 plus another one, 2, 0 plus 0 plus 0 plus 1. So here 3, 2, 1 will come divided by maximum of these three values. See this one maximum. So 3 to 1 from this one, 3 is maximum. 3 by 3 is equal to 1. 2 by 3 is equal to 0.66 and 1 by 3 is equal to 0.33. Similarly, for the remaining two also for remaining three matrix also, RDP can be estimated. Again, if you see 1 plus 1, 2, 1 plus 1, 2, 0 plus 1 is equal to 1. Max value is 2. That is 2 by 2, 1, 2 by 2, 1, 1 by 2 is equal to 0.5. Similarly, RDP estimated. Next one is relative importance performance. Relative importance performance, how it is estimated. See this one, vertical values are added. 1 plus 1 plus 1 plus 0.66. See this one, 1 plus 1 plus 1 plus 5. Vertically, all the values are to be added vertically. So if you add vertically and among that one, maximum value will be taken similar to that one, 3.33, 3.66 by 3.66, comma 2.99. 2.99 if you see, this one 0.66 plus 1 plus 0.33 plus 1. This one is 2.99. So 2.99 by maximum value 3.66. If you add all these things, you will get 1 comma 0 comma 1 comma 0.8169 comma 0.4071. So this value we get. From this one, weights are to be estimated. So in the estimation of weights, first you have to add these three. So one value will get, that is 2 point something value will come. 1 divided by that value, you will get 0.449, and this divided by sum of these three, you will get this one. 0.4071 divided by sum of these three, you will get the weights of, first one is AY, next one is CR and AX. So this one is weight of AR, this one is weight of AY, this is weight of CR, this is weight of AX. So like that, scientifically we can estimate the weight of responses. If you see the RSM method, so it is not possible to give weights there. So all the three responses will be given 0.33, 0.33, 0.33. Like that, it gives the weightage there. In this method, we can estimate the weights scientifically. Okay, weights of responses are estimated scientifically. How to get? So how to get the multi responses into one response? So generally here we have the CR, AX, AY. These are the three responses. Three responses are to be converted into one response. So how to convert that one into one response, I will show here. See this one, overall utility value. It is nothing but the three responses are converted into one response. That is called as utility value or maximum response. See this one, weight of AX, weight of 1 minute. Weight of AX, weight of CR, weight of AY. So this one is PAX. This is preference scale. Again, we have to estimate. Jagrataga vinandi, all of you. This PAX is preference scale. This one also preference scale for the CR. This one is a preference scale plus the AY. Here you need not to worry how to estimate the preference scale easily. I will tell you. Please listen to me. Okay, now you come here. So this one is construction of reference scale, where we have the three responses AX, CR, AY, and these are the how to we have the Taguchi method. Using the Taguchi method, AX you have to select as so larger the better. All of you know the Taguchi method. I think most of you know. Using the Taguchi larger the best method, because AX and CR to be maximized. AY is to be minimized because it is affecting the cap width and surface roughness. Our aim of our present presentation is also minimization of cap width and surface roughness. That is why we want to minimize the AY and maximize the AX and CR. Using the Taguchi method, we are getting the optimum current wire tension T on T off for the AX, for the CR, for AY also. In the Taguchi method, you have one facility that actually at these particular working conditions, the experiments may not be conducted. So only we conducted 16 experiments. In the 16 experiments, these working conditions may be there or may not be there. So at this particular working conditions, what is the optimum value of AX, CR, AY can be predicted in the Taguchi method itself. These are the acceptable level. Optional, here we have the option. So whatever the values we are expecting of AX, CR and AY, so these things can be selected as per your requirements. Using that one, see this one, this preference scale can be estimated. P is the preference scale, A is constant, log x dash by this one is x I dash. X dash is nothing but optimal value, this one, optimum, that is predicted optimum value. Xi dash, this is the acceptable level. So you know this value, this value. Here x dash is 43.96, xi dash is 50. And these two values you know, and p value is taken as 9. P value, that is maximum acceptable 9 value is taken as p. So we know the p value, x dash value and xi dash value also known. Using these three values, you can estimate the value A. That constant value can be estimated. Now you see, preference scale for the AX minus 160 log of AX by 50. This is maximum acceptable level. That previous slide you have seen 50 you have taken here. So that's why here we have taken. Preference scale for the cutting rate also minus 98 log of CR by C. AX, CR, AY, these are the experimental values. And this 4 is the maximum acceptable value. Similarly for the AY also 160 log of A by 10. So this 5410 can be seen, are taken from the previous slide. See this 5410 are taken from here. This is optional. As per your requirement, you can give, you can take these three values. Now, if you go to the experimental results, once you see, in the present study, we have taken CR, AX and AY. See this one, CR, AX and AY are taken in the present study. We want to maximize CR and AX and minimize the AY. That is the aim of our study. These values, see this one, clearly see these values we are using. So how many experiments we conducted here? 16 experiments we have conducted. How to estimate that one I will tell now. That utility value how to get I will tell now. Listen carefully. So far I think there is no problem to you to understand. Now see this one, overall utility value. That means the three responses are combined as converted into one response as utility value. See this one, W, these weights we have, we obtained using GTMA method. All the weights are taken, and preference scales also just before slide we constructed. See this one, AX, CR, AY. So where you have 16 experiments, in the each experiment you have separate AX, CR and AY values. That values will be taken, and finally you will get the utility value. See this one, right side you have column utility value of you taking the three responses. So using these utility values, the process parameters are optimized. So where you get optimum current, that is 3.697, Y tension is 15, 7.6364 is the T on optimum value, and the T of 60. So we optimized the process parameters here. That is 3.697, that current in terms of current, Y tension, T on and T off. So we optimize the process parameters. After that, we have to validate that one using the neural network method. Okay, I don't take much time here. Most of you hear about the artificial neural network, but you are unable to use this one. I will tell an easy method how to use the ANN for our research work. Generally, we are using the MATLAB to carry out the artificial neural network. So here in this presentation, I used easy NN plus software. That is actually, that is very easy to use. That software size is also around less than 50 MB. Size of that one also 50 MB. In the net you can download, free download. That maybe for 45 days it will come. You can easily download this, that one, and that one easy also. Okay. Artificial neural network is one kind of modeling technique using the experimental data which is already collected. So we have different types of modeling techniques. One is mathematical modeling. In this presentation, first we have seen what is that one, where used mechanistic models are nothing but semi-analytical methods. So using that modeling techniques, we predicted that is cap width and surface roughness. So next one is you have the finite element based FEM based modeling technique also. FEM based modeling technique, they use they are physics equations based modeling techniques, that FEM based techniques. So artificial neural networks, if we say, all these are data driven. So already we have experimental data. Using that experimental data, modeling for the surface roughness cap width will be developed. How to develop in this technique we see easily. We have to use the easy NN plus software. Okay, before seeing that easy NN plus, just a small introduction about the neural network I will explain. A simple network, a feed forward 4-10-3 network we constructed here. How to construct that one also I will tell. So the network consists of 3 layers. One is input layer, output layer. Between the input and output layers, you have a hidden layer. So in the input layer, if you see, where we have 4 circles. In output layers, we have 3 circles. In the hidden layer, we have the 10 circles. These circles are nothing but neurons or nodes, NOD. Neurons are nodes. So in the present study, we have 4 inputs. That's why we have taken 4 neurons. The outputs here in the study, I considered CR, AX, and AY as the responses to predict. So I have taken 3 responses here. That's why in the output layer, you have the 3 nodes. In between, we have one hidden layer. In that hidden layer, the number of nodes or neurons were taken as 10. So sometimes if the data size is more, you can use more than one hidden layer. 2 hidden layers can also be used. In each hidden layer, the number of neurons or nodes can be changed. So here I have taken 10. Sometimes I may take 8, 7, 6, for more than 4, because the number of nodes input layer only 4. That's why 5 to any number you can take. So if you are not able to get the required result, hidden layer, another hidden layer can be incorporated. There also you can change the number of neurons and nodes. Okay. Now in the present study, we used feed forward 4-10-3 network that already I explained. Okay, learning how it will take, I will show. There are 3 types of learning methods. One is supervised learning, unsupervised learning, and reinforcement learning techniques. I will tell now. Once again, I am coming here. We have set of data for 16 experiments at different levels of current, wire tension, pulse on time, pulse of time, and we collected the experimental results CR, AX, and AY. In this presentation, I took only 6 responses. Sorry, 3 responses only I took for this presentation. Actually, where we have the 6. So among the 6, I took only 3 important output characteristics I have taken here. Okay. Now, cutting rate, I already told you in that preference scale construction where we have taken 4. Okay, this network is trained with that table, experiment results table. The table consists of inputs as well as the outputs. The total data will be given to this network. This network estimates, predicts the CR, AX, and AY also. So if you see the supervisor learning, we gave the target ACR as the CR we gave 4, that is cutting rate 4 meters per minute it was given. For AX we gave around 50, for AY we gave 10 micrometers. Like that, these values we have taken as targets there in the GTMA method. Similarly, the targets we have taken here for CR as 4 meters per minute, AX and AY 50 and 10 micrometers respectively. We gave the data to this one. The data is propagated at these 3 levels, and finally, okay, first we talk about the CR value. So our target value is 4. If the after propagation of this information which is given to this one, when the network is trained, the network estimates the CR value as, say, for suppose 3.5. 4 minus 3.5 by 4 into 100, the error is more. So that error, we are getting more error. Our target error is, we allowed the error between the target value and the estimated value 1%, say 0.01. 0.01. So if the error, that target value and the estimated value is more than 0.01, then what we have to do, efficiency of these connections between the layers to be changed. Efficiency is nothing but weight of the connections. The weight of connections, that is efficiency of connections, will be changed until we get the estimated value with the error less than 0.01. So until you get that required error between them, keep on changing the weights. That is called as feed forward back propagation. That algorithm we are using that feed forward back propagation algorithm, we are keep on changing the weights of the connection until we get the error less than 0.01 between the target value and the estimated value. Similarly for the AX and the AY also. This is supervisor learning. In the unsupervised learning, whatever the error it is, it doesn't matter. Simply it is one-way process from left to right. It estimates the one output value. Whether you like that value or not, it's not matter. That value will be taken. Last one, if you see, that is reinforced learning. In that one, you don't allow until you get same target value. You keep on changing the weight of the connections. So you want to get the error between them 0. So until you get the same target value, you keep on changing the weights of the connection until you get the same value. That is called as reinforced learning in machine learning process. Now, so how to create the network, and see this one, how to create the network, how to give the input values, how to run this network, how to predict that one. All the things I will show in the coming slides. Okay, see this one, this software, how to enter the data there. This software is easy and plus everybody can download from the net. The trial version for 45 days it is available. So if you download this one, if you open that software, you will get this kind of display. So now initially you don't have this kind of number of columns, number of rows. At starting it gives only one row and one column only. So see this one, if you click here, you can increase the number of columns and the number of rows also, it doesn't matter. As for your table, you create number of rows and number of columns. So along with the software, you can download the manual also. In the manual, clearly it says how to increase the number of columns and the number of rows. So after getting required number of rows and columns, you go to the each box there, you select and you enter the value, or otherwise you can import the data from desktop to this one. So if you import that one, after importing that one, you have to specify each column. See this one, omega t on t off, and the current is also there. Current is not visible here. We have to define them whether it is input or output. See at the bottom you have input, output, and exclude. Those options are there. If the column is input, you select here. If it is output, you select here. If you want to exclude that one, you see X7, there is no data here. That was excluded. See, that was selected here. Okay, so like that. So these W2 T on these values can also be entered, that can also be written. This is about the columns, defining the inputs and outputs. If you see the rows where we have the 16 experiments, after entering the 16 experiments, in the 16 experiments, 3 experiments were taken. That is experiment 2. See this one, V2, V5, V10, and V4. 4 experiments were selected for the validation of the training. So here no data was taken from the experimental result to test the ANN. To test the ANN, another 3 experiments were conducted separately, that you will see in the next slides. Okay, after entering the data into that one, you have to define all the columns, inputs or outputs, all the rows, all the experiments. That is, what are the experiments for training and what are the experiments for the validation. After defining that one, you should go to the 1 minute. Now you should go to the action. At the top, if you see where you will get action, so you select the action and check the grid. See this one, check grid. Starting itself, we have, if you click that one, it tells you whether network can be created or not. You see that next slide, if you next figure, if you see, the grid can be used to create a network. So if any error is there, it will tell you roll number, that is row number 4 or 5. It is not within the range, it is above the range. Whether it is to be included in the training or to be excluded, like that, it will ask you according to your wish whether you want to exclude or include. As per your requirement, it includes. So where we gave 4 validating, that is 4 examples, 4 experiments for the validation. If the validation experimental value is also beyond the range, it will tell you so and so. Validating example beyond the range, whether you want to keep that one validation or exclude or to be converted into training, that it will ask. As per your wish, you will select that one. Okay, after that one, finally it will tell you the grid can be used to create a network. Now you come to this one. So however, you have the 4 inputs and the 3 outputs, and you select this in the third figure. You select the number of hidden layers. In our example, I took only 1 number of layer. 1 layer is selected. In that one, 10 were taken. 10 nodes were taken. After that one, learning rate 0.6, momentum rate 0.8, target error. See this one, 0.01. All the things you can set. And default, that network itself, default values it will take. Learning rate, default value will be there. If you want, you can change them. Okay, after entering these details, learning rate, momentum, and error, so you bother of this learning rate, whether it is 0.01 or not. You take this learning rate, momentum rate, automatically the software itself, it takes care. Whereas if you use the MATLAB, everything you have to define, connect weight of the connections, this momentum rate, learning rate, all the things you have to define. In the software, it is not required like that. Say, once you select this one, if you click the OK, now you will see the learning of this one. So this graph shows the training of the network. See, at right side we have training examples 12, validation examples are 14, target error 0.01, average validating error and average training error are got less than 0.01. For that one, weight of the connections between the input layer and hidden layer 1, the software itself has taken 40. For the connections between hidden layer 1 and output layer, that weight was taken as 30. I told you, if the error of average trailing error is found more than 0.1, the software will change the weights until the error got less than 0.01. So if the software is not able to get the error less than 0.01, then what you have to do, you have to go back okay, 5 minutes I will close. Listen to me. Okay, now you come here, one number layer, hidden layer, another hidden layer is to be increased there also until you get the error between them less than 0.01. You keep on change the number of layers and the number of nodes in the layer, and finally you will get the error between the that is error of the average training error and average validating error got less than 0.01. Then you stop that one. How to stop this one? In previous slide, where you see at top you go to the you go to the action where you have the stop learning. So if you click the stop learning, it will be stopped, and there itself you have the query. If you select the query, first it gives the add all values. See this one, like that you will get. If you go to the query, this will be displayed. If you give the input values I, W to T on T of values, it predicts the output values. So for testing of this one, I separately conducted 3 experiments and compared the predicted values with the experiment values. All the things we got error less than 5%. And see this one at bottom, the optimization which is done by the GTMA method are validated with this ANN method. All the predicted values are found to be close with the experimental results. Then the optimization is also validated. Thank you very much. That validation is also optimized. If you have any doubts, please ask me. Thank you very much. Please ask me if you have any doubts.
Sir, thank you, sir.
Thank you.
Sir, Leela Prasad, sir.
Sir.
Sir, Leela Prasad, sir, he has collected 2 questions.
Yeah.
He will now raise the questions.
Please.
Sir, thank you, Dr. Venkatrao.
Thank you. Thank you, sir.
Sir, your session is very informative and very interesting.
Thank you.
Because of technical.
Hello?
వాడు అదే టెంటివ్ అని చెప్తున్నాడు. ఫైనల్ ఇయర్స్ కి ఆల్రెడీ జరుగుతుంది.
Please.
Sir,
Please.
sir, can you tell us the name of the software?
Easy NN plus.
కానీ గ్యారంటీ మాత్రం తెలియదు.
Easy NN plus. Okay.
It is very easy.
Okay. Easy NN plus.
EASY, NN plus.
Okay. So that question is from Arshad Mahmood. And one more question, sir. It is from Benjamuri Venkata Kamesh. Can you please tell about, why the last row of PG1 matrix becomes 0?
Which one? Can I share?
Why the last row of PG1 matrix becomes 0?
You see, to get one value, there must be a connection from one response to another response. Between them, we have any another circle, another response, it will take 0. There must be a direct arrow from one response to another response. If you don't have the direct arrow, automatically it takes 0. Based on the arrow, from which, for suppose from CR to AX, if you have arrow, it will give 1. From CR to AY, if you don't have the arrow, upward arrow, it is taken as 0. That based on the preference graph we constructed, we get the 0 or 1 value.
Okay, sir. Thank you, sir. And one more question, sir. Can you please tell us about the research work on dry EDM? This is from Lakshmipati Erra.
Dry EDM. Already EDM was expired. That is evaporated in that EDM. Okay, they can do one thing, sir, that latest metals we have, latest composite metal matrix composites we have, which are used in latest applications in biomedical, in that applications, the metals which are using made by the composites. So on that one, you can do the wire EDM or EDM, no problem. That something must be new. Either material is to be new, methodology, or the experiment. Some novelty must be there. You can do it, no problem.
Okay, sir. Sir, last question, sir.
Yeah.
How do you select orthogonal array in Taguchi method?
That is based on your number of levels which you have taken for the experiments as per your requirements. See, nowadays nobody bothering of the design of experiments. For suppose if you have 3 input parameters, there must be 2 levels in each input parameters. That is enough. You need not to bother about the DOU also. The input parameters which you have taken in that one, in each one there must be 2 levels. That is enough. No need to go for any design of experiments. All the response surface method, all the Taguchi method supports the what I told. That kind of design of experiments also.
Thank you so much, sir.
Thank you, sir.
So all the entire session is very informative and very interesting, and I assure all the participants that no technical problems will crop up in future from our side, and I request Venkatrao sir, please share his email through chat, so that
Okay,
our participants can ask additional questions to you, sir.
Okay, I'm sharing my mail ID.
Sir,
You can contact me. I shared my mail ID.
Sir, can you please name the software once again?
Easy NN plus. That one also I am sharing.
Okay, sir. Please, sir.
That one also I shared.
Okay. Thank you so much, sir.
Thanks.
Thank you. So now I request my colleague, Dr. Devprasad sir, to introduce the next resource person.
Good afternoon, everyone. Dr. P. Janakramalu is the Associate Professor in the Department of Mechanical Design and Manufacturing Engineering and Director of Center for Advanced Manufacturing Engineering at Adama Science and Technology University, Adama in Ethiopia. He completed his Masters in Manufacturing Technology Engineering from NIFT, Ranchi, obtained his PhD from IIT Guwahati. His research interest primarily includes advanced metal joining techniques, friction stir welding, sheet metal forming, Taylor welded blanks, CAD/CAM modeling simulation of metal forming process, metal characterization, welding technologies, different metal forming process analysis. He is specialized in experimental and modeling simulation of sheet metal with different formability tests. Dr. Janakaramulu has more than 15 years of rich experience by working in the field of teaching and research. His research work contributes the sheet metal forming entitled Forming Behavior of Friction Stir Welded Sheets made of AS6061 T6 alloy to the field of sheet metal forming with latest joining techniques. He has published more than 120 papers in international journals and conferences. He has guided 36 UG, PG, and 30 PG projects, guiding 6 PhD students. One completed his doctoral thesis under his guidance. He has been conferred the Best Student Paper Bronze Award in international symposium held at Hong Kong. He has participated and presented papers in 15 international conferences across the world, organized, and he has also organized 2 international conferences, one in India, one in Ethiopia. I welcome Janakaramulu and take over the proceedings.
Thank you very much, sir, for your kind introduction about me. How we are like a brotherhood relation. Thanks to Leela Prasad sir for inviting me to deliver the expert lecture.
Thank
and
you, sir.
the Vignan College management and the co-faculty of the Vignan Colleges. I welcome all, and today I am going to deliver about my I'm going to deliver on mathematical modeling impact on welding process. So the previous talk which I have seen, Professor sir, he has given very high dose technical oriented lecture, which I may not deal that much technical aspect. I will give a general aspect of the mathematical modeling impact on welding process and what can be done further for who are coming to the welding research area or who are working in the pure experimental aspect research. So what can be done and how we have to think for the mathematical aspect of any technology can be studied now and can be seen through my lecture here. So before going to my presentation, I must introduce about the institution where I am working since 5 years. So this is what the partial view of Adama Science and Technology University. Shortly, we will say ASTU. So you can see this is the main entrance of the institution. And these are the complete campus view of the ASTU. It is around 500 acres area. And these are our mechanical workshops where we can do the experimentations. And this is what the admin block, and now it has been shifted to the new block. So in this Adama Science and Technology University, more than 5,000 people are working. And in that 5,000, 120 members are from Indian professors are working in this institution. It's very proud that in Ethiopia, this is the top 2 university among 40 universities existed in the country. So it is comes under the Ministry of Science and Higher Education. And it is closely monitored by the ministry, which has a lot of funds for the research, and we are getting so many facilities and opportunities to work in various departments and the various aspects of researches. So apart from that, ministry has given the permission. Ministry has proposed a proposal to establish the centers of like advanced manufacturing engineering, electric power control and communication engineering, advanced material science engineering, urban housing development, and water resource and irrigation engineering, transport and vehicle engineering, space technology institute, Institute of Pharmaceutical Science. So these all 8 centers of excellence are being establishing in this institution, and we are going to start full-fledged centers into 2021, which will be very sooner. And the equipment what we are going to plan and what we are going to establish in especially in the Center of Excellence and Manufacturing Center, if you see, these are the basic labs which will be established with high precision level machineries, followed by the different manufacturing thematic areas, which will be equipped with the advanced research equipments, which we will need to support for the industries which are nearby the Ethiopia, or we are going to expand our center to the other African countries also. So if you are going to success with the facilities which we proposed, then it will be a very good research center in the country. We are expecting that, and we will move further for establishing this one. And very happy work in the Adama Science and Technology University. The environment, the working environment, as well as facilities aspect is really wonderful working environment in the Ethiopia, we can say. So when I'm coming to my presentation, just I may speak about brief introduction on welding process, how the welding process have come, and what makes the welding to the advanced level of technology, and what type of welding processes we have, and possible forces in the process, and the mathematical significance in the process, how the mathematical modeling can be done for the welding process can be seen. So this is the hardcore manufacturing classification aspect. This slide will tell you how the manufacturing classification have been taken place. So if you see the manufacturing aspect, so if you want to see where mass can be changed, phase can be changed, structure can be changed, deformation aspect, consolidation aspect, we can classify the process of the manufacturing. And also with respect to the workpiece material, on what workpiece material you are working, what type of equipment you are using, what type of work zone you are working, and what type of interface you are maintaining, and what type of tool we are using. So based on that, and also based on the different new materials also, the entire manufacturing classification can be taken place with respect to the materials, with respect to the physics, with respect to the tooling aspect. We can classify the process. So the origin, when you talk about the manufacturing, how that idea has come and how this manufacturing process have been classified. If you go and see our mythology, Kamadeni, if you see, manufacturing, if you are talking about the manufacturing, it's a mother for all the products, where Kamadenu is like our mother, where the all gods and goddesses will exist on the Kamadenu. We believe that Kamadenu is like a idea for our base for the manufacturing aspect, and how we have derived our manufacturing products with respect to our mythology. If you follow our mythology, you will get so many ideas of the research, and you will work such a manner, and you will not deviate from any other thing, and you will further move it into a pinnacle positions. And when it's coming to the introduction of welding, so it was started actually metal manufacturing process. If you talk, metal working is the first process, where metal forming process you will say it was started 8000 BC back. So when it coming to the welding aspect, it has began at 4000 BC. Then it has started with the 4000 BC, and it moved further, and it become very popular, and it is becoming it took so many years to reach to the advanced level of the process. You can see no need of studying all the stories here. So it was started from the 4000 BC, still it is going on, and you can see how the welding impacts have been taken place in the various stages of the manufacturing process. Without welding process, now speaking and joining of the different kind of materials with respect to the thickness aspect, with respect to the material aspect, there are so many possibilities to make the weld and to make it a workable function, a workable aspect, and it will be done in a systematic manner, and it is giving the very good efficiency with respect to the performance aspect. And when you talk about the classification, how the welding can be classified. So any subject, any engineering aspect, if you talk, we need to recollect our physics principles, and we need to see on what base weldings can be classified, and what base and weldings can be done, and what materials can be welded. If you talk in that way, so weldings broadly, so far, 4 classifications you can see. These 4 classifications only, the entire welding processes will come into picture. So for example, if you see welding with or without filler material, source of energy for welding, what type of source you are using for the welding aspect, whether you are going for the filler material or not, arc and non-arc welding process, and fusion and pressure welding process. So based on these four ideas, based on these four phenomena, the welding process have been classified, and it is now it become so many processes existed in the welding with respect to the material aspect. If you see in that also, when you are going for the large melt full welding process, if you see, you can see how expensive welding process and how much energy will be consumed to make the welding joining of the materials. You can see the large melt full welding process. We can talk with respect to the tungsten inert gas welding aspect, how much energy we are giving and how much melting we are generating during the welding process, how large it is, how much large we are using that. And similarly, manual metal arc welding process also, if you see this, it will create huge large number of molten melt full zone it will create. And similarly, submerged arc welding and metal inert gas welding also the similar. So what is the problem with this? When it's creating large melt pool, what is the problem? So thing is that when you're going to generate large pool, then we will experience that instead of joining where the expected joining is somewhere 5 mm thickness aspect, but it is melting the 10 mm thickness as 10 mm width aspect, then the significance of the welding and the metallurgical behavior of that particular welded joints will differ. And also when you're seeing the process, you should not, you can see like a technician, you can see the process like how the welding is done. But when it's coming to the engineering aspect, you need to see how many parameters are involved in that process to get a defect-free weld. And when it's coming to the research aspect, you need to think as a technology aspect, as an engineering aspect, followed by the science. And when you're coming to the science, you need to study about the mathematical aspect. So when you're identifying the parts, or when you are labeling the process, each label will have its own impact, and it will create a lot of impact on the weld joint performance. So when you are going for the process, you need to know how many process parameters are involved for a process. And when it's coming to the, based on this, that's how the evolutions will come into our mind. And you can see when large melt full welding processes existed, why didn't you go for the narrow weld full processes? It's obviously it will come. So when it's coming to the narrow, the advanced technology which is coming out and it's already working in the process. And when it's coming to the narrow aspect, if you talk, there is a laser welding process and the electron beam welding process. What we see here, it looks very simple, but when it's coming to the process optimization, when you're talking about the process parameters involved during the joining of the different materials, how it can be worked out and how it can be processed and how we can utilize the proper parameters of those processes and how we can minimize the energy consumption and how we can go for the perfect joints can be further. So this is what you can see, the melting of the material and joining the material. So you may think here, why don't you join the materials without any melting point? Is it possible? So evaluations will come like that. With the evaluations only, enhancement of the process will be implemented. So based on that, and if you see, it layman question, and the layman may ask the doubts. So when we might have studied, we studied a lot of physics about the welding or something else. So if you see what type of forces will involve in that, if you see the pictorial form, because these are the forces which are highly responsible to deposit the molten metal to join the different materials. So if these forces are not working properly, then joint formation may not take place properly. So when you are going for the process, we need to see how the material is depositing on the other material or the filler material on the proposed joint. So for that, how many forces are involved during the process? So for the significantly, if you talk, two ways of the things we need to observe. That is, flight duration of the molten metal drop in arc region affects the quality of the weld metal and element transfer efficiency. This itself is a one research topic you can take. Flight duration of molten metal drop in arc region affects the quality of the weld metal and element transfer efficiency. When it's coming to the other phenomena, arc forces affect the deposition efficiency. Suppose that if you take the first one, which is, we can take gravitational force, that means droplet is coming down and going to drop there on the proposed joint. Where if this gravitational force is not properly acting, if it is not acting properly, then the droplet which is coming out from the filler material or the whatever, then it may not deposit on time, then the quality of the weld will differ. And similarly, when it's coming to the second one, this surface tension aspect, which is acting towards the electric gun or whatever the arc generation thing. So if these all forces which are responsible for the joint deposition efficiency, and these forces will impact, because when you are welding towards the gravitational direction, the droplet formation is very simple. But when you are welding vertically, then how those droplets will deposit and how it will be done. So this is like a question, how we can do the welding in this direction. If you are going to do welding in this direction, no problem. But when you are going vertically is a problem. So in that case, how we are going to avoid such problems and how we are going to give the proper justification for the thing. This is what the arc problems you can see. But we are already discussed melting the material and joining the different materials. Why don't you avoid without any melting zone? For that only, this solid state technology has come. Solid state joinings have come to make the welds without any melting of the materials. For that only, there is a cold welding, roll welding, explosive welding process, ultrasonic welding process, where the few things which are we can see here, how the welding can be done without any melting thing. But these materials may not give, this process may not go for the high thicknesses or the different type of materials or the high strength materials. In that case, what has to be done? The advancement has to be continuous, right? So whatever the solid state joining techniques which we see here, it may not suitable for the use number of means different type of materials or different thickness of the materials or heterogeneity. When it comes, it may not be suitable for that. In that case, further advancement has to be done. For that advancement only, therefore classified again 4 manners, that is diffusion bonding aspect, plasma assisted diffusion bonding aspect, and the rotary friction welding and the friction stir welding. So the current scenario, when it's going to the diffusion bonding, it will talk about the atomic level, how the atoms will dislocate and deform from one material to the other form. The diffusion bonding will explain how it can be done. When it's coming to the plasma diffusion bonding, then the atoms will come out and it will go to and deposit to the other places. With the anode and cathode mechanism will be implemented. Then with that it will go and it will weld both the material. By applying the huge pressure on that, then it will be done. When it's coming to the rotary friction welding, this is what the highly solid state welding process, where by rotating the two things and we can melt, we will generate the pressure over that and the welding giant formation will be done. So when it's coming to the frictional welding, which is a advanced welding process so far till date, and it is the most popular process for especially non-ferrous materials. The extension of this frictional welding, in addition to the non-ferrous too, now it is welding the steel materials and the non-ferrous materials also, and also non-ferrous to the polymer materials also are going to join. Such a beautification happened in the over evolution for in the welding process. So what impacts will create when we don't care about this, the mathematical modeling of the welding process? Simply studying the technology may not be sufficient. For that, what has to be done? The mathematical significance, if you see here, mathematical significance, if you see, previously, where this aircraft, we know most of the aircraft body is made up of the aluminum alloys. So when it's coming to the aluminum alloys, they used to join with the rivets, joining of the different structures with the riveting joints. So when you are doing the riveting, if any failure comes, you can see the failure happened in the rivet. Here also you can see how the rivets have been opened here. When rivets opened, what could be the situation of the passengers when they are in the air? Right? This is another research area, you can say. So when rivets have been replaced with the advanced technology, you can also see further failures in the rivets. This is one of the components which we will use in the aircraft. The rivet is being opened and the crack propagation has been happened, then the entire structure may be collapsed. And similarly, you can also see how the rivets are coming out of from that slot over a period of time. You cannot say that rivet is highly defective technology. We cannot say that. But over a period of time, when the too much fatigue happened in the structure, then this type of failures will be observed. So when the failures are happening in the structure, especially the aircraft which will go with high velocity, when this type of problems comes, then how to avoid those problems? We cannot go and repair immediately. It is not possible. So similarly, you can also see the motivation, how it is coming. The motivation aspect, if you talk, the rivets, 3 rivets we have been used to join a simple material. Why don't you join simple with the solid state welding process? If you join them, you can replace the entire thing. And similarly, how many rivets you have been used, simply you can replace the thing. And also, if you want to see a differential thing, see how many rivets are used here. Simply you are going for the welding of the thing. This will be done with the laser welding, and this is how we can replace the existing technology with the latest joining process. And when it's coming to the when it's coming to the significance of the mathematical modeling for this process, if you talk, significance of the mathematical modeling for any mathematical model. So when you are going for this one, there must be a physical system. So by seeing that physical system, you will get some ideal system. From the ideal system only, the process will be done. This is what up to here, up to this zone is a ideal system. Then you will go for the welding process simply. Means whatever the process it could be. But when you introduce about the mathematical representation of the ideal system, by incorporating the governing equations, problem domain, boundary conditions, and if you go for the welding process, then he will give you the proper and perfect solution for any kind of problem. Why we want to go for the mathematical modeling process. Why don't you use directly with this process? People have studied already. And if you see the significant level, how much welding is being used for the automotive aspect. If you see a simple automotive body, by utilizing of the mag and TIG welding process, how many parts have been welded for the automotive body. This is one type of process. And similarly, if you go and check the another process like the advanced welding process, like laser welding process, how many parts have been welded? And if you are able to identify, even though each welding has its own defects, its own problems, but even though if you are going to overcome, if you want to overcome such problems, and if you want to make the perfect weld of to such products, especially when it's coming to the laser welding aspect, will be a keyhole problem. If you see this diagram here, microstructure aspect, when you're joining the materials, then there is a problem of the keyhole. And how many process and how many parts will be generated during the welding, and how the solidification will take place, how the molten fuel will be generated during the welding process, you can see here. And similarly, when it's coming to the friction stir welding aspect, now the concept came called the tailor welded blanks. How much tailor welded blanks can be generated to make a automotive body, you can see from this picture. Thing is that without doing any prediction work, without doing any simulation work, without doing any mathematical model, without doing any numerical techniques, if you go and join directly to this type of things, what will happen? This is the question which will come. You need not to think too much about the mathematical modeling, but when you are going for such processes, the advanced level of process, directly if you implement your ideas onto the product without a proper justification in the science, then what type of problems can be seen? See, the history will tell you the reason behind the mathematical modeling. This was happened in 1943, where what we are talking about, the final element modeling techniques or mathematical modeling techniques. At that time also mathematical modeling was there, but they don't know how to use to the manufacturing process. Every technology, at that time also mathematics was very vast. People were developed such things, non-linear models are there, but they don't know how to use it. Such a huge mass body has been broken at the welded joint. So in such case, just imagine the loss occurred for a particular government or particular country. When it's coming to do which was happened in our India, because of the thermite weld fail, the entire rail become derailed. You can see simple defect created the lot of problems for the entire structure. So what has to be done? How we will proceed? Whatever the predefined models existed, what can we use for that? Or we have to develop the new thing for the problems which are raised in the history? What has to be done and how we are going to solve such problems? For that only, mathematical model give you the whatever. We cannot say that it will remove all the problems which are existed in the welding or any kind of process, but it will give you the moral. It will generate the confidence in the researcher to explain to the industry person to take their ideas and implement to the real-time products. For that, when you are going to develop the mathematical model, you need to think by yourself, what is your objective and what we are going to find, what type of parameters are existed, and what model predictions we are going to do, whether that model is valid or not, that has to be verified in an appropriate manner. If you see this flow chart, will give you the complete picture about the principle of the mathematical modeling of the process. So you can say objective or system. In that, why you have chosen that objective and what we are going to find from that objective. And for that, what type of model we are going to construct for that. So when you're going to consider a model, the pictures we have seen in the previous slides, the parameters involved in the process has to be identified in a systematic manner. And we need to see which one has the more impact during the process. For that, the end model will be developed. And when it's going on and how we are going to process, what type of things we are going to improve, and what is given already in the system, and what we have to assume for that one, assuming in the sense so many parameters will come, and what we are going to predict, followed by the model prediction. And we need to verify, we need to test it, not through the experimentation, through your mathematical model. By solving the problems you need to solve. With a simple problem, we can check it and we can go for the complication problems. For that, when you're going to develop the mathematical model, you need to follow these four phenomena again. That is, dimensional homogeneity and consistency has to be maintained. When you're writing the equation, you cannot combine the x, y, z of the three different phenomena and we will put together. No, you need to see the dimensional homogeneity and consistency. When you are writing the like a Bernoulli's equation, there are so many energy heads are there. When you're making all of them, it has to be constant. Similarly, when you're writing the expression, when you're developing the model, you need to see the dimensional homogeneity and consistency of that particular equation. And we need to see how much level we are going to extract and out of how much level you are going to develop. This is what the abstraction and scaling will explain you. And we need to also see conservation and balance principles. That's what we are talking. The energy, whatever we are consuming and whatever it is giving as output and whatever in between, that has to be balanced properly. Then only it will be make it as a unit system and it will work without any problems. And constructing the linear models. Make a complicated system. Take the complicated system, because in one process, in one welding process, you will get plenty of process parameters. In the plenty of process parameters, you may not take all the parameters. But when you are considering all the parameters, it will become a nonlinear thing. When nonlinearity you want to develop, first you have to understand the linear things. So develop the linear models, then make use of those linear models to give it to the complicated problems. And so when it's coming to the welding aspect, what we need to observe from the welding aspect, what is the multi-physics involved in the welding process? If you see, when you are going for the mathematical modeling of the welding, first we need to see the metallurgical analysis, mechanical analysis, then the thermal analysis. That means the hardcore areas for the welding process as a fundamental engineering aspect for any mechanical engineer, definitely they will go through the metallurgy and they will see the mechanical like strength of materials, mechanics, and the design of whatever. And the thermal analysis, whatever thermodynamics, what we studied, thermodynamics, thermal engineering, heat transfer, these all fundamental phenomena has to be combined, should explain as a multi-physics aspect for a mathematical developing. So when you are writing such things, you can also see further the expression, because you can simply say the welding process as a thermal, metallurgical, mechanical interactions. You can say thermal, metallurgical, mechanical interactions during the welding. So when we talk about the temperature, there will be heat conduction, because metal contacting and heat is being generated. When the heat is being generated, then thermal conductivity principles will come. Not only thermal conduction, so many principles will be related to the thermal will come. And when it's coming to the material deformation, because material is going to melt means it is going to elongate, it will deform, it will take the deformation, then it will go to the fracture level, then it will drop on the another material. In the solid state, you can take the flush size the material, then it will form the joint. So when it's coming to the stress analysis, the deformation phenomena will take place in the material. So the stress and strain relations has to be known. So temperature aspect, that will be thermal stresses or the heat conduction, whatever. And when it's coming to the stress and relations, you need to know the linear elasticity model, linear plasticity model, and non-linear elasticity models, non-linear plasticity models, inelastic behavior, and viscoelastic behavior. All these stress analysis will come into the picture, and along with the temperature. And it's coming to the metallic structures aspect, how this grain formation takes place, or how the solidification will take place once the joint formation occurs. Because the solid, when it's coming to the casting, we are doing only some alloying elements or the pure materials. But when it's coming to the welding aspect, there are different types of materials with different phenomena will be there. We are going to join. So those kinetics we need to explain in terms of the grain growth and the grain formations aspect. That means it is also going to the molten level and how it will be done. So this relation will explain about the stress and strain induced phase transformation. When it's coming to this side aspect, temperature dependent structure change. How this with temperature and stress will be related to the thermal stresses. So heat generation due to the mechanical work, latent heat, transformation stresses. So these all are the fundamental concepts one has to know when we are going for the mathematical modeling of the welding process. And when it's coming to this one, to make you more understandable, we need to see the fundamental diagrams which are existed for our metallurgical aspect, like a iron carbide diagram and time temperature transformation diagram. Both will explain you how the molten metal is going to solidify, what type of phases will take place, and at what level of temperature, what phase is existed. These relations have to be maintained, because once the heat is given up, we know that steel will take place around the 1550 degrees centigrade, it will melt and it will give to the liquid phase. When it's cooled down, then we know that perlitic structure, austenitic structure, ferritic structure, cemented structure, all will come into the picture in this diagram. So this is your fundamental thing. That means heat gaining, heat losing, energy transformation, energy generation in the material during the deformation or the melting. Those all concepts has to be interlinked to your fundamental subjects of the mechanics of solids as well as the thermodynamics principles. We know up to here, the 400 degree only we have syndicated. That means in the iron carbide diagram, up to 800 degrees centigrade, it will indicate. Below what happened, the TTT diagram will explain you that. So these two diagrams will give you the complete kinetics involved in the grains of the phase transformations of the any kind of material. From that only, we are going to start our governing equations of the welding process. So we know when you talk about when you see the microstructure or the phase transformation which will happen during the iron carbide diagram or the TTT diagram, so many constants will be developed during the phase transformation or the solidification or any other thing. So when you are going to develop the governing equation, now we have n number of elements we have. That means n number of phases will be existed. N number of constants will be there. And then those, how much volume it has, that volume has to be considered by appropriate functions. So when it's coming to the combination, all these combinations of the constants can be expressed in terms of the x is equal to 1 to n, I is equal to 1 to n, x and zeta 1. So when it's coming to this number of constants, So this when I is equal to 1 to n and xi and zeta 1. So this will indicate about the volume aspect, and this will indicate number of constant existed, and this will indicate the what type of fraction and what type of elements which are combining together. And whereas when it's coming to the volume consistency, if you combine all of them must be equal to 1. That has to be followed. Volume consistency should be mentioned. Now, when you are talking about the thermal aspect, when you're talking about the mechanical aspect, when you talk about the metallurgical aspect thing will give you the entire, it's like a mesh in the Fahrenheit model. So it's a metallurgical aspect. When you see the number of constants existed in the equation, in the phase, you need to quantify them and we need to give the expression. And we have to use our fundamental expression, which will be 100% will be used in the metallurgy, that is Gibbs free energy. By taking a small equation, how we are deriving to the three-dimensional aspect, how we are expressing to the so many parameters involved in that. If you see, we know that Gibbs free energy will explain that it is a, you can say enthalpy, the summation of the enthalpy minus temperature into the entropy. This will give you the how much energy has been utilized for the phase transformation. It's like a free energy aspect, where enthalpy, whenever it's coming, so it will explain the how much energy utilization. That means it will talk about the internal energy aspect and it will explain about the internal energy aspect. So this further you can, if you want to write into the three-dimensional aspect in a stress tensors formation aspect, if you write it, Gibbs free energy equation, you can express like a internal energy aspect, entropy and temperature aspect, and your whatever the mass density aspect. So internal energy density aspect, temperature and entropy density aspect, and the mass density aspect, we can talk the Gibbs free energy formation. Now we know internal energy when you talk, which is responsible for the phase change. That means deformation aspect or the phase change aspect or whatever microstructure change aspect we can talk. And when it's coming to the stresses and strains, that will be the completely talks about the shape change of the any kind of material. So those things can be expressed further by considering the all the parameters. I may not show the complete derivation here, but the governing equation, the fundamental equations which this is the fundamental equation. From that, how we are deriving to the three-dimensional aspect, how the expressions will be explained by in terms of the thing. If you see, elastic strain rate can be expressed with respect to the inelastic strain rate from the total strain rate. If you want, this is what your total strain rate. This is inelastic strain rate, and this is your elastic strain rate. And for the constitutive equations aspect, this Gibbs energy is in terms of the so many parameters. This we know: stress, temperature gradient, so inelastic strain rate, and the thermal stresses aspect, and the hardening aspect, and the volume consistency aspect. And similarly, entropy also can be influenced all the parameters. And similarly, you can also express the with respect to the stress aspect, with respect to the strain rate aspect also. And when the heat is introduced about that one, that whatever the internal parameters summation, if you want to see, these governing equations can be furtherly we can express in terms of the thermal stresses aspect, inelastic strain rate aspect, and hardening aspect as well as volume aspect we can talk. This how these equations will gather together, and it will give you the mathematical model of any kind of welding process. So the only thing, when the material is changing, these parameters will change, because material aspect, these parameters will be decided with respect to the material behavior. And when you talk about the conduction aspect, the same equation can be further we can write. Generation of the heat flux also will be there. When you talk about the heat conduction aspect, similarly internal energy aspect and the mass density aspect and your heat generation, water heat flux aspect if you talk, and you can express the heat conduction equation by introducing the enthalpy which is involved in the during the solidification of, or during the melting aspect, how much energy can be consumed, that can be expressed by the enthalpy aspect. That's how the heat conduction equation will be generated for the welding aspect of the any kind of welding process. And so what the thermal analysis and the weld pool will give you is how many things, how many parameters, and how many, that's what I'm talking about, the multiphysics aspect. So if we know, very familiar with the Fourier's law, based on that Fourier's law, the expression can be combined with respect to the your specific heat aspect, with respect to your energy aspect, with respect to the conductivity aspect, with respect to the heat convection aspect, and also whatever the external thing which is aspect. So we can write the thermal analysis of the for the welding phenomena, and we can express this equation. So based on your input, based on your ideas, based on your material behavior, these equations directly we can use this equation by knowing the material behavior of that particular thing. And also mechanical aspect, if you talk about the mechanical aspect, how many strains involved during the process, and what type of strains will happen during the welding process can be expressed here. The effective strain you can rate, strain rate can be expressed in terms of the elastic strain, plastic strain, thermal strain, volumetric strain, and transformation strains. So these all strains. So whenever we are introducing the strain with respect to elastic strain, we have the relations between the stress and strain in the elastic zone, and we have the relations in the plasticity zone. We have the relations with respect to thermal strain, with respect to the volumetric strain, and with respect to transformation strain. But generally, the transformation strain will not be considered. So the whatever the change in the strain we will see, that will be expressed in terms of the 4 important strains. So combining of the thermal aspect, combining of the your Gibbs energy equations, combining of thermal conductivity, thermal analysis, and the mechanical aspect and metallurgical aspect, the entire mathematical modeling of the welding can be expressed. And further, based on your knowledge and based on your interest, you can expand the relations and you can derive the expressions for the mechanical aspect with respect to the any welding process. You can write the expressions. So when it's coming to the automation aspect, because whatever the thing we are doing, so to avoid the defects only, the mathematical modeling has come into picture. So from that understanding of the mathematical modeling, developing the so many codes for the machinery and the automation have come into the picture. That automation involves how the adaptive control system and how the flexible manufacturing systems can be developed, how simulations and the offline programming can be maintained, and the integrated automation systems can be implemented, and rapid prototyping can be processed, and how wear replacement can be done. So these automations with respect to your mathematical modeling can be implemented to evaluate and to justify why we need to go for the automation aspect for any kind of welding. So this automation is your advanced area of research, the process. So each and every topic will give you the research area for a new researcher who are working. We want to work in the welding aspect. Don't think in the conventional manner. The conventional things already done in a sufficient level. So when you're going further and when moving towards the automation level, we are expecting from the researchers how we can adapt the systems and how we can go for the automation aspect and how we can justify the automation for the industrial problem, and how we can avoid the defects and how we can improve the life of the product for any automotive industry or any kind of automotive things. That's fine. So mostly the welding softwares people use Abacus and the Simufact welding and the ANSYS can be done, and so many other softwares also there. So based on that, but they are commercially available, also some cracked versions also available from this. You can learn and you can practice those, and you can see what is happening, whether whatever the mathematical expressions given in the existing literature is working or not. You can check through these softwares. The simulation will give you the 90% of risk riskless for the any experimentation thing. So that's how we can proceed for the mathematical aspect of the welding process. And when it's coming to the role of a manufacturing engineering, being a manufacturing, you must be proud. People will think that manufacturing is a very easiest and very simple. You can say as a for the sake of degree aspect, people do manufacturing. It's wrong. We know that 60% of the income is depends on the manufacturing industries. Not only for particular to country, for any kind of country, especially developing countries, the manufacturing industries play an important role. Whereas for the developed countries, automation level of the manufacturing is also important role. So when being a manufacturing specialized person as a researcher, when you are going to choose the problem related to the manufacturing, choose the heart burning and the existed problem and how you are going to provide the solution for the existing problem and how we have to simplify the process and how we can make it to the a small scale industry level, how we can prolong the technology to that level. So we need to simplify the complicated system effectively and think ahead about the industry future and society towards the environmental impacts. After this pandemic situation, the entire world is going to change and the manufacturing sector is going to be leading for the economy. So we need to be ready for any kind of consequences happening during the COVID. And we need to think about the national economy aspect. We need to give different ideas and we have to give the students and we have to make the students such a way they must be like an entrepreneur, especially in the manufacturing area. Then definitely our economy will improve and world level healthy environment will come into the picture. And when the technology aspect, what we are talking, and if you are being a Hindu or if you are a Hindu or some other religion, because I'm a Hindu, I know about the mythology, something about the Hindu. So technology behind our Hindu mythology or the history, if you see, what we are talking about the Vimana, that means it's like aircraft we are talking. When your Vimana is derived from the Sanskrit word, VI means very high. VI indicates the very high. Mana means is a moving object. So with high velocity, which is moving, that is called the Vimana. This was there in you might have seen our mythology, Pushpaka Vimana, where gods, they used to travel very quickly and they used to communicate quickly information. And when it's coming to the remote sensing aspect, what we are talking now, remote sensing, this was there during in the Mahabharata, where Dhritarashtra, you don't see these incidents, but by telling someone, he will visualize and he will imagine what is happening into the battle, and he made that thing. So that ideas only our latest technologies now. And during the war in Ramayana and Mahabharata, we have seen they used to use the Brahmastra, some other very powerful weapons. That is what the nuclear technology have come now. That means they know the technology, but they use it in the different manner. Now what we are using, in future it may not be the same. But when it's coming to the other like a space technology aspect, if you see, this was also indicated in many years in the olden days only in our mythology. And when it's coming to the civilization aspect, we know Mohenjo-daro and Harappa indicates the very classical structures. Still they are existed, and how they did the very advanced level of agriculture aspect. They showed up to us. From that only the technologies have come. Many scientists indicated India is the origin for the entire culture and as well as the entire technology. Without Indians, no technology, no science, no culture. They told in so many ways. Such things I have proof for that. If you want, I will share later. Thank you very much.
Thank you, Janaki Ram.
Okay, thank you, sir.
Thank you, Janikram. We have Dr. Suresh Akella from Shreyas Institute of Engineering and Technology. So he
Yes,
has
sir.
question. He will now ask question to you directly. I must just unmuting him.
Yes, sir.
Sir, Suresh Akella, sir, can you start asking question? Sir, Suresh Akella, sir. Sir, can you start ask question? Suresh, sir. Sir, Suresh Akella, sir, can you start asking question? Sir, can you ask question? Sir, can you please enable video audio? Suresh, sir, can you please enable audio? Suresh, sir, can you please enable audio? Suresh, sir, can you please enable audio?
Sir, good afternoon, sir. Suresh, sir.
Can you unmute?
Sir, your idea is mute.
Am I audible now?
Yeah, yeah.
Yes, sir. Yes,
Hello?
sir. Audible now. Okay, yes, audible
Yes,
sir.
sir.
Now.
Sir, it is one of the best lectures I have heard on welding technology, sir.
Thank you,
And
sir.
I was in modeling welding for some time. And
Yes, sir.
compared to what you have presented, what work I did is very minimal, I feel like. And there's clarity on the physics. Yeah.
Sir, continue, sir.
Can I continue?
Yes, sir. Yes.
Hello. Yeah, I think in many aspects you have covered everything, the physics of it and the practical welding process of different welds, and also the modeling, the steps involved in any physical modeling to get useful output. You have very clearly given in very nice format, sir. One request is the PPTs available for us to refer in future? That is one nice.
Sure, sure. No
That's
problem,
very
sir.
nice
I will
input,
give.
and
No problem, sir.
because a lot of work you have put in each and every aspect. Only thing is it will help either students or staff to learn and proceed in that manner what you have done. That
Thank
is
you,
one
sir.
thing. And
Thank you, sir.
I mean, I did very little, like I was mostly involved in the physical modeling and the boundary conditions. I was very intricate parts are there, like how to involve the latent heat into the appropriate phase change model, how to involve the flow rates. So many aspects, like welding is a very involved physics, mechanical engineering, every aspect is covered. One question is you have covered the Gibbs free energy also.
Yes, sir.
It can be used for whether the welding is possible or not also we can use it. Suppose if you are doing some welding, sometimes it is possible physically or not. By calculating the Gibbs free energy, we can do that. Did you try that any time?
One more question.
Yeah, yes, sir. Whatever model we are doing for the especially mathematical aspect, so thermal analysis and the structural analysis we are combining and we are studying.
Especially
Yeah,
the
that's how
Gibbs
we are
free
moving.
energy.
Yes,
Gibbs
sir.
free energy will tell you whether the possibility of a weld process can naturally happen or it may not happen. Then it will give you that answer, sir.
By default, it will come into the picture, sir. Whenever welding mechanism
Yes, sir.
comes, Gibbs free energy will involve by default.
Okay, sir.
Yeah, sir.
Okay, sir.
Thank you,
you.
Sir, Dr. Janikramul, sir.
Yes, sir.
Sir, there is one more question.
Please, sir.
Is there any procedure to select
Voice Rawat.
optimization method for
Sir,
similar welding?
అది ఎనేబుల్ చేయలేదు మీరు ఆడియో Audio. Unmute చేయండి.
Yes, sir. Sir, are you able to hear me?
Yeah.
Sir, it is from Sairam Kotari. Is
Yes,
there
sir.
any procedure to select the best optimization method for dissimilar building?
Optimization techniques are different and mathematical modeling is different, but you can choose the optimization techniques. Like if you can choose the ANN model and you can make the process optimization.
Okay, sir.
Yeah.
So any other questions?
One second. There's one more question. I'm just unmuting that one person. Let me. There's one more question from. Yes, please go ahead.
Hello, Janki sir.
Yeah.
I am Vishwajit, your junior in Guwahati.
Yeah. Vishwa, you are so interested. Oh, thank you.
No, nicely. Actually, you are coming. I just yesterday only I have registered for this course, and
Okay.
to imagine what we have read in our institute that is completely fresher now, and it's a very
Okay.
opportunity for all of the faculty members and students who are attending this to expose at least what are the basic of this manufacturing. As we see,
Yeah.
metal forming and welding is nowadays having applied while as well as aerospace structures. The lecture was very nice. Just I have one question that regarding the material selection for now date or till date, which material is particularly in aluminum I am asking, in aluminum series, which material is one of the best material to go for research work, particularly the young researchers, he may be doing MTech or PhD. So which material if he will choose for metal forming or welding, particularly in aluminum series, which is good?
Yeah. Vishwa.
Yes.
Now most of the research have been done on the aluminum alloys.
Yes.
Now people are moving towards aluminum and composite joining and aluminum and polymer joining.
Yes. Okay. Thank you.
These are the now latest topics we can choose.
Yes.
That's what people are telling, metal matrix composite. Apart from metal matrix composite, now our friction stir welding is doing aluminum and polymer joining techniques.
Okay.
So that's what.
Thank you very much.
Thank
It's
you.
a nice presentation.
Thank you.
Thank you, Janakram.
Thank you very much, sir.
Thank you for sparing your valuable time. And we will have feedback from our whatever the participants that will be shared. This recording, YouTube recording is there. It will be there and you can download at any point of time.
Thank you very much, sir.
PPT, somebody was asking if you share, you will share with all other people.
Sure, I will send it, sir. No problem.
Thank you, one and all.
Okay, sir.
Sir.
One second. Yep, please.
Dr. Janikramulu, sir.
Yes, sir.
From the reaction of all the participants, I can judge that your presentation is excellent, sir. Thank you so much,
very much, sir. Thank you, sir.
And and I want to make
South Africa, Ethiopia.
Hi.
I want to make small announcement for all the participants. Tomorrow we have only one session, sir. And due to time zone issues, tomorrow's session will start at 12 p.m. as scheduled. Okay. So, thank you so much for all the participants and all the both the resource persons. Thank you, sir.
Okay, sir. Bye, sir.
Bye, sir.
Thank you all.
Thank you all. See you. Meet tomorrow. We'll meet tomorrow.
Thank you, sir. Thank you very much.
Hi.